We are now moving into our next chapter in the book. So this is chapter 4. And we're kind of starting out with some stuff we've already talked about. So today is kind of just going to be a vocab check-in, and we're going to hit the ground running. Okay? So for here, just some vocab check. We're talking derivatives, so we're going to be talking about our rates of change. If you remember, we've talked about averages. So if something was asking for the average value or the average velocity, the average acceleration, to find the average, you're going to find the slope of the secant line. If you remember, the secant line has 2 points on the curve. So if our curve looks something like this, I could take this point and this point and just simply find the slope between them. So that's, again, any average that we're looking for. Average value, velocity, average slope. Just find the slope between those 2 points. It's the slope of the secant line. All right? We've talked about instantaneous rate of change. An instantaneous rate of change, instead of finding the slope between 2 points, which is an average, we're going to find the slope at 1 point. The slope at this 1 point is the same as the slope of the tangent line. So again, if we had some curve, we're finding the slope at this 1 point, which is our tangent line, like this. We also know that this is where we take the derivative. Okay? All right. More vocab. If we start out with our position formula, and I take the derivative of position, well, that's going to give me velocity. Okay? So I guess I'll call this position so we know what's going on. And here we know that this is velocity. So the first derivative of position is the velocity of our particle, our movement. If it's a positive velocity, that's telling us direction. That's like we're moving to the right or we're moving up. If it's negative, this means we're moving to the left or down. And again, it just kind of depends on what our particle is doing, how it's moving. Okay. If we were to take the absolute value of velocity, that's when we're talking purely speed. So velocity is speed and direction, but if we ignore the positive and the negative, that's just the particle's speed. Okay. And if we were to take the derivative of velocity, that means we're looking at acceleration. Acceleration is the second derivative of position. Okay? Pretty straightforward information there. We've talked about it for a while. We should feel familiar with that. Last thing I want to talk about is how do we know if our particle is speeding up or increasing in speed, or if it is slowing down? We know our particle is speeding up when velocity and acceleration work together. So if my velocity and my acceleration are both positive, my particle is speeding up. If my velocity and my acceleration are both negative, my particle is speeding up. It's increasing in speed. But if my particle is slowing down, that's because my acceleration and my velocity are working against each other. So there's a little bit of friction or tension there. So if my velocity and my acceleration are opposites, one is positive, the other is negative, they are working against each other and our particle is slowing down. Okay, like I said, this was a little bit of review, some vocab. There's only 7 problems on the homework. Give them a go. If you got questions, email me.